Friends, welcome to my channel MP Educate. I am Mita Parekh. In this video, we are going to discuss about most important diagram based question of chapter 4 Science 1. Before starting the video, let us understand the importance of the diagram based question with the help of the paper 2020. First question is always objective question, that is of the 10 marks. In the question number 2, students have to attempt any three. Here 1 and 2 are the diagram based question. In the question number 3, students have to attempt any 5. Here 1, 2, 3 are the diagram based question. In the question number 4, students have to attempt any one. And here 1 is diagram based question. Friends, you have noticed out of 40 marks question, 20 marks question are the diagram based and 10 marks question are objective. So friends, if the students do the diagram based question thoroughly, then definitely they will get 40 out of 40 marks in their Science 1 paper. Let us move our first diagram based question. Explain the diagram, friends. Here in the diagram 1A and in diagram B. So diagram A is about the Fleming right hand rule and diagram B is about the Fleming left hand rule. Here we have to label the diagram. Friends, in the Fleming right hand rule as well as in the Fleming left hand rule, the index figure always show the direction of the magnetic field. So here at the index finger you have to write down the direction of the magnetic field. Friends, we know the Fleming right hand rule is about the direction of the induced current. So at the middle finger we have to write down the direction of the induced figure. But in the Fleming left hand rule we have to write down the direction of the current. Friends, we know that the Fleming left hand rule, it gives the direction of the force on the conductor. So here at the thumb we have to write down force on the conductor. But in Fleming right hand rule we have to write down motion of the conductor. Let us discuss the Fleming left hand rule. Here, according to this rule, the left hand thumb, the index finger and the middle finger are stretched such a way that they are mutually perpendicular to each other. When the index finger shows the direction of the magnetic field, the middle finger shows the direction of the current, then the direction of the thumb is the direction of the force on the conductor. Let us see the Fleming right hand rule. Stretch the thumb, index finger, middle finger in such a way that they will be perpendicular to each other. In this position, the thumb indicates the direction of the motion of the conductor. The index finger shows the direction of the magnetic field. Then the middle finger shows the direction of the induced current. Let us move to our next diagram based question. Identify the figure. Friends, here the battery is shown in the diagram. So it is electric motor. We have to label A, B, C, D, E, F. Now A is iron core, B is coil, C and D are split ring, E and F are carbon brushes. What is the function of C and D? C and D are the split ring and the split ring reverse the direction of the current in the coil. If in the first rotation the direction of the current is from A, B, C, D, then after the half end rotation the direction of the current is from D, C, B, A. Now state the uses of the E and F. As we know, E and F are the carbon brushes. The carbon brushes are used to press the split ring on the axle. On which principle does this equipment work? Friends, when the current carrying conductor placed between the magnetic field, then it experiences the forces. Now, according to which law does the coil ABCD move? In our first question, we discussed the Fleming left hand rule in detail and we we say that Fleming left hand rule always shows the direction of the force on the conductor. So here we can write down according to the Fleming's left hand rule, the coil ABCD rotate. Write the law in your own word. We have already discussed in before question. Where where is this equipment is used? So this equipment is used. This is an electric motor. So electric motor used in fan, refrigerator, mixture, washing machine, computer, pump, etc. Let us move to our next diagram based question. Here, friends, which rule help us to find out force experienced by the current carrying conductor in above diagram? Friends, here the magnet is given and there is a current carrying conductor placed between magnetic field. So in first question we have discussed that force experienced by the current carrying conductor always shown by the Fleming left hand rule. So we have to write down here according to the Fleming left hand rule we find the force experienced by the current carrying conductor. We can find the direction of the force experienced by the current carrying conductor. Now, what is the direction of the force experienced by the conductor when the current is in downward direction? So, when the current is in downward direction, then according to the Fleming left hand rule, the conductor experiences the force outer side. And when the current is in upward side, then according to the Fleming left hand rule, the conductor experiences the force inward side. Now, when the force experienced by the conductor is maximum, here the force is maximum when the direction of the current is perpendicular to direction of the magnetic field. Now, which principle is explained in above figure? In before question, we also discuss about this principle. Let us discuss again. When the current carrying conductor placed between the magnetic field, it experiences the forces. In which machine this principle is used? It is used in the electric motor. Let us move to our next diagram based question. Here, state the two factors on which the strength of magnetic field for the circular loop depend, or how can you increase the intensity of the magnetic field around the loop. Here is the loop, and when the current is passed through the loop, there is a magnetic field produced around the loop, and it is seen in the form of concentric circle. How can you increase the intensity of the magnetic field? So, the intensity of the magnetic field increase the current, or it can be increased by increase the turn of the loop, number of the turn of the wire in the loop. Now, let us see our next question. Concentric circle become concentric circle bigger and bigger away from the loop. These are the concentric circle. It become bigger and bigger as we go away from the loop. So away from the loop, the intensity of the magnetic field decreases, and therefore concentric circle representing the magnetic line of force become bigger and bigger. As you go away from the loop, the intensity of magnetic field is decreases. Friends, have you seen that the sub question of the diagram based question are too simple to give answer. So please do diagram based question and get 40 out of 40 marks. Thank you for watching my video.